Good morning, friends. This is Durga from IT University. Those who are joining on YouTube, as you guys are aware, this is just a backup for my live audience. So, in case if we could not answer your questions, just bear with us. We will try to answer your questions as much as possible in live chat. If we could not, you guys can definitely follow up, and we will try to respond to you. Let's move on. And as of now, we are primarily talking about HDFS. So, if you go to the documentation, which I'm referring, which is Apache Spark using Python. Yesterday we were talking about file systems overview, and as I have explained, as the Spark doesn't have any inbuilt file system, HDFS APIs, whatever file systems HDFS supports, Spark. Inside HDFS API supports HDFS itself, S3, which is a cloud-based storage from Amazon, which is Microsoft Blob Storage. Understand the nuances about what needs to be done to connect to AWS S3 or Azure Blob. That being said, we also have gone through the demo covering all these important commands such as ls to lift the files, copy from local, or put to copy files from local file systems into HDFS, to copy files from HDFS into local file system, mkdir to create the directory in HDFS, rm to delete files or directories, cat to see the content. I have not demonstrated cat, but cat can be used to see the contents of the file. And we will see that quite a bit of times in future, so I'm not going to demonstrate at this time. Tail is to just print the last 1 KB of single file on standard out in HDFS. It is typically used for previewing the data. And finally, we have seen this command called HDFS FSCK. Whatever cards I have copied into HDFS and demonstrated how we can get the metadata. And also we have seen how to customize the parameters or properties such as block size, replication factor, etc. using -D. Even though I haven't documented here, I have demonstrated and I have shown you. Okay, so make sure you understand that not only properties such as block size or replication factor can be overridden using -D. Anything that is there as part of core site.xml or HDFS site.xml can be overridden using -D control argument. Okay, but typically we use it for uh, um, changing the block size, replication factor, and a few more things. Okay, that being said, now let us understand the architecture of HDFS a bit in detail and what it actually gives us as part of HDFS. What is HDFS and how it is deployed on the cluster? What are different components? What are the purpose of each of these components, etc. For that, I'm going to Ambari. Okay. If it is Cloudera distribution, you will have Cloudera manager. As we are talking about Hortonworks distribution, my lab is built on Hortonworks distribution. That's why we are connecting to Ambari. And every one of you will get access to Ambari once you have active subscription to the lab. That being said, here we are talking about HDFS. What is HDFS? HDFS is nothing but a bunch of binaries. Okay. If you go to the gateway node, so here I'm connecting to the gateway node. And when I set up cluster on all the nodes, how many nodes we have in the cluster? We have 10 nodes in the cluster. That you can get by clicking on hosts. You can get all the nodes in the cluster. So whatever you see here, each of these nodes will have binaries deployed. What are those binaries? They are nothing but jar files compiled from Java. And in this case, the location will be /cd /user HDP, and then latest version will be at current. Current is nothing but soft link for the latest version. Okay, and then you see there are subdirectory for each of these things. You can see HDFS, there is a client, there is a data node, there is a journal node, there is name node, there is NFS3, so on and so forth. There are so many components within HDFS itself. But you don't need to worry too much about it. Understand that all the services which we are seeing in Ambari, all the services which we are seeing in Ambari, software deployed on all the nodes in the cluster at different levels, and some components not only get the binaries but also daemon process that will be running all the time. Again, we need to understand the architecture while deploying, and that is the pain of the administrators. As a developer, you don't need to worry too much about the nuances of setting up the cluster and all. Architecture at a higher level, um, and uh, 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 and the underlying binaries, properties files, what are the processes that will be supporting these things. FS, all the binaries will be part of these directories. Okay, if I go to one of the directories, let's say I want to go to Hadoop HDFS data node and ls-ltr. You see, there are a bunch of jar files. Okay, so these are the jar files, nothing but software to support one of the components in HDFS. Okay, and then if you go back to the hosts, there are gateway nodes. There are two nodes which starts with NN, which is nothing but name node. NN stands for name node, and there are WN, which stands for worker nodes. And these are all names for the hosts. The physical servers are named like this, just to understand what is the purpose of a given node. Okay. And now if I go to services and click on HDFS, you can see there is a name node, there is secondary name node, and there is data node. And if I click on data nodes, you will understand on what all nodes this data node is running. So these are the physical servers on which data node is running. What do you mean by data node is running? It is nothing but a daemon process running on the cluster. Okay, there seems to be some questions. Yeah, I will get to the gateway node in a moment. Let's start with data node, then name node, then we will go to the gateway node. Okay, so that question will be answered. Okay, so what is a data node? So these are all names for the physical servers. And if you click on these 24 components on the right side, okay, you will see what all are deployed on this. One of the things which you need to focus is the data node. What is this data node? It is nothing but a software process which will be up and running all the time. And what is the responsibility of that data node? To keep track of blocks that is there on each of these nodes. Yesterday, when we run that HDFS FSEK on the path, you got the files, blocks, and locations, right? And whatever blocks for a given file are stored on this worker node, data node is responsibility to keep track of those things. Okay, and and it will have the information about all the blocks it have, and also it will communicate with the client to copy the files. So whenever I run Hadoop fs-put command, client will directly talk to data node, and data node will take care of saving the files, which are nothing but blocks on its corresponding node. And if I connect to one of these worker nodes, you will not be able to do this because you are having access only to gateway node. You don't have access to any other node. And this is how a typical clusters will be accessible for developers. So developers will never have access to all the nodes in the cluster unless it is required for troubleshooting, where you have to raise a ticket and admin team will give you access. Typically, will have access only to gateway nodes. You will not have access to any other nodes. Okay, and that is how you got access to the lab also. You will be only able to access on gateway nodes. You will not be able to access the other nodes at all. but I will be demonstrating from my side. I'm connecting to the lab with a elevated user. Okay. And now if I say PS-FU, HDFS, HDFS is a OS user who is the owner of this data node process, software process. You can see here. There's a process running proc underscore data node. This is a daemon process. Daemon process means the process which should be running in the background permanently. So data node is a daemon process which will be running on all the slave nodes, whose primary responsibility is to maintain the blocks for the files which we are trying to copy. Okay, and it sends heartbeat to its master. So there is a master for these things which will coordinate with these things, and we will get into those details a bit later. But for now, just understand that there is a master, and this data node process will keep on sending the heartbeat to the master saying that I am alive. So that master keep track of all the data nodes and decide using which data node data should be copied, and all those things will be taken care by the master. So who is that master? Now, if you go back to HDFS service, on top of data nodes, you see a name node and a secondary name node. So name node is the master. Okay, so data nodes will send heartbeats to the name nodes by default every second, saying that I'm alive, and name node will keep track of, and along with heartbeat, it also send what is the free storage data nodes have, and many other information. So, for example, on the worker node, if I run this command called du stands for disk usage, or df -h, which is nothing but free disk on the server. You can see that there is a HDP01 and HDP02, which are configured as data nodes. Sorry, directories for data nodes. So these are the directories which will actually save the files. All the blocks will be preserved in these directories. How it is decided on this, I will show you in a moment. You can see here the size of these two mount points. These are mount points. Okay. As most of you are not very comfortable with Linux, you can consider them as hard disks. So this is one hard disk, and this is another hard disk, or a partition. You can either consider it as a hard disk or partition. So one hard disk or partition is 1.6 terabyte, and other hard disk or partition is 1.8 terabyte. Out of this, one actually occupied 496 GB, and other occupied 499 GB. Okay, and this is the available storage. 1.1 terabyte on one and 1.3 terabyte on other one is the available storage. This information will be passed along with heartbeat to master, which is nothing but name node. So name node will maintain how much storage is taken by each of the data nodes to preserve the files. Okay. So when we run Hadoop FS command like this yesterday to copy the files, the client will talk to the name node, and as the name node keep track of the the storage utilization on the cluster, it tell which one is free, which one is occupied, and then client will work with those data nodes to copy the files. Or when I say files, they are nothing but blocks. Okay, so this is how uh, the load balancing and all those things are taken care. Okay, there seems to be a question here. Typically, there is a concept of JBOD. Again, this is mostly administrator thing, or architects also should know. So if you want to understand, there's a concept of JBOD. JBOD stands for just a bunch of disks, which means we give raw hard disks to the worker nodes without configuring RAID or anything, and then we will format with ext4 or ext3, and then we will define as part of the properties that it should use this mount points. After formatting, we will mount, and then we will tell HDFS to use this directories. And the naming convention of these mount points or directories pointing to the mount points have to be uniform across all the worker nodes. Okay, good question, Shaili. I hope it got clarified. Okay, that being said, now name node is the master. So data node will only know what all blocks it have. Name node is the one which will keep track of the file name, the the blocks associated with the file, and the location, whatever command we ran yesterday. When I This is the command, right, which I ran yesterday. So whatever output we are getting, the files, blocks associated with the files, and the locations of the files. This is nothing but metadata of the files, and this metadata will be preserved in the name node. And name node is nothing but a daemon process similar to data node, plus a memory structure to keep this metadata. It's a in-memory structure. It's not a file structure. It's a in-memory structure. Name node is nothing but in-memory structure for your metadata, which is nothing but files, blocks associated with the files, and the locations. So only name node knows the mapping between files, blocks, and locations. Data nodes doesn't know. Data nodes only know what blocks it have. Only name node can determine the relationship between the files, blocks, and locations. Okay. So name node is nothing but a daemon process similar to proc underscore data node. There will be something called proc underscore name node, and also the memory structure which will keep track of this metadata. Why in memory? Because the performance of accessing this metadata from memory will be much faster than performing IO and read from the file system. Okay, so for that reason, they decided to put all this metadata in memory. But that being said, memory is transient. If the server goes down, whatever contents in the memory will flushed out, right? For that reason, they maintain a couple of file structures, which are called as FS image and edit log. I will not get into too many details here, but whatever will be preserved in the name node will kept track by using these couple of additional file structures, which are called FS image and edit logs. Okay, and at times they have to be there need to be some bookkeeping happening, and that bookkeeping will be done by another service called secondary name node. So name node is the one which will actually keep track of metadata in memory, and also it will take care of load balancing the storage on the cluster and all those things. And secondary name node is just helps you is just there to keep track of support name node. It's a helper to name node. It is not failover or anything. It's just a helper to name node. So whatever FS image and edit logs we are talking about, they are predominantly managed by secondary name node. Okay. So that being said, don't think too much about secondary name node at this time. Just understand that there is a master or set of masters and a bunch of slaves. Slaves are the ones which will store the data. Masters are primarily to coordinate and keep track of metadata of the data. Okay, that is about HDFS and its architecture. Now we have already seen properties from the command prompt yesterday. We went to etc Hadoop conf and we have seen the properties. Those things can be accessed using further service. There seems to be a question. I will get back to that in a moment. So you can see here configs. So there are typical arguments or important arguments which are displayed here, and there are advanced. Okay. So as part of the typical settings, you can see the name node directories, data node directories, and this is where I have configured the hard disk to which data should be written. Okay, so HDP01 is one mount point, HDP02 is another mount point, which will be there on all the worker nodes. And then I have told, okay, under HDP01 for HDFS, use Hadoop HDFS data. On name node, for FS image and edit logs, these are the directories. And also, name node should have a memory because all the metadata has to be in memory. I have given 16 GB memory for the name node to keep track of the metadata. Data node also will have memory because there's a daemon process called data node which needs to be up and running all the time. We can leave the default 1 GB is the default, and we can leave for data node. We don't need more than 1 GB even in a very big cluster. So these are the settings, behavior of your data node. Okay, so we started with jar files, and then we I have explained about different daemon process such as data nodes, name nodes, etc. And then configs properties. So any software, okay, not only HDFS or big data related technology, any software will have these things. There will be a software or binaries. There will be daemon process. There will be property files. If you understand these things, you will be able to understand the engineering of any software solution very easily. Okay, so there are only three things: one, binaries or software; two, daemon process; three, properties or config files. That being said, let me take these questions. So Shaili is asking, so NN seems too important. What happens if it goes down? Who will be the next master? Secondary name node. Very good question, Shaili. It's more of an admin question, but still I will answer that. The secondary name node is just a helper. And as you mentioned, name node is very important. If it goes down with this architecture, okay, let's say name node goes down, there will be a downtime until I recover the name node and restart the cluster or bring the cluster out of safe mode. There will be a downtime. Depending upon the cluster size, it can be 10 minutes to couple of hours also. Secondary name node is not failover. To address this issue on critical clusters, with Hadoop 2, they introduced a concept called active passive configuration. With active passive configuration, you can enable the failover and all those things, where the downtime will be within seconds to a couple of minutes, irrespective of the size of the cluster. Okay, so if you are interested, if you want to know how this high availability can be taken care, you just have to understand the active passive configuration of HDFS. Yes, that's correct, Shaili. So Sumit is asking, where are software installed on data node, name node? Is it on local file system of data node? That's correct, Sumit. Anytime, take any technology, softwares will always be installed locally, which means binaries to support a particular component will always be installed locally. So in this case, the same set of binaries are installed on all the 10 hosts. Okay, if I say HDFS is installed on 10 nodes, each of these have the exact same copy of binary set up on all the nodes in the cluster. But the difference is what daemon process are running on what nodes. So in this case, these worker nodes have data node, NN01 have name node, NN02 have secondary name node, and then RM01 doesn't have anything. It has some other thing called resource manager, which is related to YARN, which is a processing framework. As of now, we are only talking about file system framework. And gateway nodes also doesn't have any daemon process. That's why they call it as gateway nodes. Okay, so the difference between different types of nodes in the cluster is based on what daemon process they are running. When it comes to binaries, each of these 10 nodes will have the same copy of binaries deployed locally, and that is the case with any software. You have to set up software locally on the PC. If you're from Oracle background, even if you set up Oracle Rack, even though your data will be stored on common storage, the Oracle binaries will be deployed on each of the node in the cluster, and each of the node will have its own properties file. Same is the case with Hadoop or any software or any technology. Software will always be installed locally. Period. There could be very extremely exceptions, extreme exception scenarios, but Typically, softwares will be set up locally. Now I'm getting into the gateway. So Sri is asking, in which version do we have HERNN? It is Hadoop 2. They introduced this high availability on name node. It is called as active passive configuration. You can check on my YouTube channel. You can just search for HDFS active passive configuration and you will get some videos on it. As it is more of a admin related stuff, I'm not covering here. So now I'm getting into gateway. So gateway is not specific to Yarn as Amit is thinking. Gateway is gateway. It's like client. So the other terms which we use for gateway are, let me type here in the chart, gateway, client, edge. In AWS world, they use a term called bastion. These are the different terms they use. Okay. So gateways are created to access the main cluster. Okay, to access the main cluster as a service, not as a physically connecting to those things. So gateway, if you look at the components on the gateway, you can see most of the components which are there on gateway are nothing but clients. So it will have access to the cluster, whether if it is HDFS, you will be able to save files, you will be able to retrieve files from HDFS and all those things from the gateway. If it is a MapReduce job, you will be able to submit jobs from the gateway. If it is Spark jobs, you will be able to submit jobs from gateway. That's it. Okay. The reason why there is a separation for gateway is so that, let's say there is a bug in your code, there is a memory leak. If there is no separation of these gateway nodes, and let's say I start running jobs on name node or resource manager or worker node, any of these nodes, let's say I start submitting jobs from, because your job, your code have bug and it has a memory leak, what will happen? Your whatever node you are trying to run your program will the side effect of that will be that it can go down because of the memory leak. It can get crashed. So to make the main cluster immune to the application bugs and also many other reasons, I am just giving one reason. There are many other reasons due to which the gateway node concept came into picture. And gateway nodes are introduced, and all your jobs will be running from the gateway node, so that even if there is a bug in your code, only gateway will go down. Your cluster will have no issues, and also if you think about it, big data is a downstream application. We'll be getting data from different sources, HDFS, right? Or we will be periodically we'll be getting data from different sources into HDFS. So if you understand the data integration framework, we typically get data to file servers, which will be network mounted, and from there we'll be loading into the servers, and then if it is Informatica, let's take the example of Informatica. So Informatica server will have a file servers mounted onto them, and Informatica server, as part of the framework, you will process the data and you will archive the data onto the file server again. The processed data will go to a target database, right? And there will be SLS. Let's say there is a bug in the code, or there are some data issues, and if you have to reprocess, you can reprocess because data will still be available in archive as per the SLS. Okay. So for all those practical purposes, same is the case with HDFS. There will be file servers mounted on the gateway node. Means when I say HDFS big data cluster, there will be file servers mounted on the gateway node. You will be processing the data, archiving the data from the gateway node. And then if you have to reprocess, you just get data back from the archive and reprocess and load the data into HDFS. So gateway, as the name suggests, is gateway for each of the service we have on the cluster. It could be HDFS, it could be MapReduce to process the data, it could be Spark to process the data, and many other things. So gateway is primarily to access the cluster uh, by making cluster immune to side effects of your frameworks, bugs in the code, etc. Okay, and if you have a 1,000 node cluster, approximately 980 nodes will be worker nodes. Majority of them will be worker nodes, and then there will be 8 to 10 masters. So 980 plus 8 to 10 will be 990. And then there will be something called utility nodes, which is where we will have some MySQL database to support the cluster. And a handful of them, like 4 to 5 nodes, will be gateway nodes. Okay. And gateway nodes are the ones which will be used by the multiple applications to submit their jobs, to load the data, and all those things. Is primarily to deploy and run your applications. Is it clear? Okay, so gateway is same for each of the service we have. That's correct, Shaili. It is a kind of BAU server. Uh, that that's correct. The wall is mainly for storage plus computational usage or processing usage. Any question here? It's very important to understand the architecture of the cluster. Even if you have 1,000 nodes of the cluster, I'm re-emphasizing 980 nodes will be worker nodes. Approximately 8 to 10 nodes will be master nodes. So if it is HDFS, there will be at least 2 name nodes like this. And when we set up masters, we don't have multiple masters on one node. For obvious reasons, masters are more critical than anything else. So to make them immune to side effects of other services, masters will have only master of one particular service running on them. Node and on these things. Rest of the stuff are primarily clients. Okay, and then there will be handful of gateway nodes which will actually be used as BAU servers, as Shaili mentioned, and that is how the cluster will be set up. No, worker node is worker node. Worker node will have all the worker components of different services. So from HDFS perspective, worker nodes will have data node. From Yarn perspective, the same worker node which have data node will also have node manager. From Impala perspective, there will be something called Impala D. From HBase perspective, there will be something called HBase region server. So worker nodes will have workers of all the services where worker component is involved. Some services doesn't have worker components, but things like HDFS, Yarn, Impala, HBase, all these things have worker nodes, and those all will be configured on these worker nodes. As per my understanding, gateway nodes perform read and write operations. I think it is not the correct way of putting it. They are not just for to perform read and write operations. It is much beyond that. It is primarily to submit the applications, to process the data, to load the data, and all those things. Everything have to do read and write operations of one sort or other. The primary difference between gateway node and the rest of the nodes are gateway node are the ones where we'll be submitting the jobs from, and then that job will be executed on worker nodes in the cluster. Okay, so probably you might get it as we proceed further and start writing the code and start executing Stravia. So don't worry too much if you don't understand exactly what gateway nodes are meant for. Okay, so a lot of these guys, Amit, Shaili, all these are experienced professionals, so they will be able to grasp this much better than freshers or those who are pursuing masters, who are um, who might not get as quickly as the experienced professionals are. don't worry too much if you don't grasp these things. As long as you understand how the clusters are configured, that is more important than understanding the purpose of these components at this time, or these type of understanding the purpose of gateways, masters, and slaves at this time. As you proceed, practice, and understand the execution, you will get it. Don't worry too much about it if you could not get 100%. Okay, so that being said, let's move on. So I am again getting into the services HDFS. We have already seen configs, software process running on the cluster, and also the binaries. Now, on top of these things, when you set up name node in a cluster, name node also have a subcomponent called name node UI, name node web UI, which is nothing but name node web interface. So if you are using Ambari, once you click on HDFS, if you go to quick links, you can see name node UI here. You can click on that, and it will redirect you to the name node UI. And even though there is a quick link here, is not part of Ambari distribution. It is part of HDFS name node itself. If you have name node running on the name node with this port number, this is the default port number. If the administrators change, it will be some other port, but typically they will not. 0 is the port number. So you can access your file system from here also. Okay. So that being said, you can get details about the cluster. You can see there are 5 live nodes, which are nothing but data nodes. The configured capacity is 16.45 terabytes, which is nothing but the cumulative capacity of the HDP01 and HDP02 on all the worker nodes. As of now, 2 terabytes of storage is used out of this 16.45. And there is non-DFS used also, means some of the storage might be used for non-DFS purposes. So this is all the cumulative details about your storage capacity, which is configured on the cluster on worker nodes. Okay, you can click on this and get the details about the worker nodes and see how much each of these things are occupying. Okay, and on top of it, you can also go to utilities and click on browse the file system. Due to certain restrictions, you will not be able to access everything, but you can go to the public, and you can actually get whatever is there in public, because public is readable for everyone. So in this case, I'm going to cards. There is this large deck file, and you can see the block size is 128 MB, replication factor is 3, size is 693 MB, and click on largedeck.txt. You can see the index for the blocks 0 to 5, the size, and the nodes on which the block have the copies, etc. So whatever output we have seen yesterday using HDFS FSCK, okay, that output will be rendered in the form of web UI by accessing through this. Okay, it is only the interpretation of whatever output we got from here in web format. So if you want to get if you want to understand how the files are stored, this is one clean way of getting the information. But you will not be able to access any other location in user unless you have the read permissions. As I have limited access, most likely will not be able to get the details from your files. For that, you have to use HDFS FSCK. But if you just want to look into the files that are in public, you can go to public cards and check how the files are stored in HDFS. Okay, so that being said, that wraps up HDFS. Even though I have covered a lot of theory, the most important part from the certification perspective are these commands. And if you want to understand more about HDFS, you can go to this playlist. And I'm sorry. Yeah, you can go to this playlist, and You can see everything. HDFS have high availability. All the commands, I have covered all the commands um, as part of HDFS here. You can go through these videos, especially senior folks who are having 10 plus years of experience. It will be good for you to explore this a bit in detail. That's correct, Sumit. You will not be able to access from web interface because I have limited the access. There is another way of getting the access, but due to the limit of the time and as it is not that important, I'm not focusing on that. Uh, when a file is so she is asking when a file is stored in HDFS, does it also include the replication factor? If we store a file in HDFS and the file size of HDFS says 6 MB, actual size is 2 MB, assuming the default replication of 3. No, that is not correct. Here it is actually giving the original size of the file. 693 MB is the original size of the file. That's why you see 6 blocks here, and each block have 3 copies. It's the other way around. This is the original size of the file. If you want to get the actual HDFS size, you will not be able to get here. But if you go to the ORU, and when you look into the capacity, whatever is displayed here includes the replication factor. So if the average replication factor is 3, somewhere it should have the details. Somewhere have. Okay, not here. Anyway, don't worry too much about it. Let's assume that average replication factor is 3. In that case, as of now, only 1.5 terabytes of data is stored in our cluster. But when it comes to individual files, it is actual size of the file itself. Okay, so that being said, let me take Shaily's question. How important it is to know the block slash HDFS file distributed location from dev point of view? Not much. From dev point of view, you should be primarily focused on this Hadoop FS is more important than anything else. Hadoop FS utility. And also, if you are a Java developer and if you want to customize the framework, you should know the HDFS APIs, which is nothing but org.apache.hadoop.fs. But from the Spark context, you don't need to worry too much about it. There are enough APIs to deal with multiple or different types of file systems. Hence, getting into HDFS API is not typically required. In case it is required, you have to explore and you have to customize it for your purpose. That being said, any guy who want to work with HDFS should be clear on all these commands as much as possible over a period of time. These 25, 30 commands. This is more important than anything else. Out of this also, hardly 10 to 12 commands are important. Others are not that important. So any other question before we move on to the next topic? So as we discuss about the distributed file system, now we are getting into the execution framework. Okay, one of the execution framework in big data, which is very popular, is YARN, yet another resource negotiator. Okay, so even though it is primarily considered as framework for processing the data, predominantly, as the name suggests, it is primarily a resource negotiator. And then the execution framework works can be plugged into YARN. Okay, so YARN is a general framework to manage the resources, and different execution frameworks such as MapReduce is one, and Spark is two. These frameworks can be plugged into YARN. So YARN will take care of resource management for the tools like MapReduce, Spark, etc. And the execution framework of the underlying technologies will take care of processing the data, and we will see those details in a bit later. Let's first look into look into yarn, and then we will see. So yarn stands for yet another resource negotiator. It also follows master and slave architecture. Let me zoom in a little bit here. 1 minute. Okay, let me. Yeah, this is better. Okay, yarn also follows master and slave architecture. Resource manager is master, and node manager is slave. And node manager run on all the slave nodes, which keep track of resources on individual nodes. And this information is passed on to resource manager at regular intervals, again with the concept of heartbeat. And resource manager will use this information from node managers and keep track of all the resources on the cluster. And then when the job is submitted, there will be a per job application master, and that will keep track of the life cycle of the job. So to understand this, let me write a simple Spark job, and then I will explain. Okay, so I'm launching PySpark here. Hyphen master yarn conf spark.ui.port equal to 12456. Okay, and then I am saying num executors as 20. Don't worry too much about what is this 20, what is this num executors. For now, just understand that I'm giving 20 executor capacity to process the data. I will come back onto these important arguments once we understand the APIs a bit in detail. Here I am trying to customize the framework to give more resources to run this a bit expensive job. So I'm launching PySpark here on the cluster. So as I have explained here yesterday, this is nothing but the driver program. If we try to relate to the diagram here, so by saying PySpark, I am creating the Spark context as part of a driver program. So whatever is launching is nothing but a driver program. And I have defined executors as 20. So instead of 2, which we have seen yesterday, now there will be 20, which will be created on our 5 worker nodes. Okay. And then there will be a cluster manager, which I will show you in a moment. Okay, so there is some issue here. No space left on device. That is bad. I'm coming out here. Oh my God. Okay, so here I have to fix few things. Just give me a moment, okay? It will take some time for me to fix this. Bear with me because the file system is full. Zero, let's go to 017. Okay, du minus. I don't think. Okay, du minus sh. Okay, cd ambari server plus -ltr rm ambari server dot star. Okay, du minus sh. Okay, so that's good. HBase rm minus rf. How come? Okay, where is different? So I'm deleting on a different file system. Plus -ltr du minus sh. Du minus sh root. This could be the reason. I have to clean up on the root. Okay, it's only 628 MB. That is not the problem. Okay, let me see. Home is different. Where is different? OPT is different. What else I have? Let me see. It could be temp. Yeah, it is temp, I guess. CD temp. Df minus h. Yeah, I too feel so, Shelly. It could be temp. Okay, so let me see what I can delete in temp real quick. For now, I will just move everything from here to, no, let me see, TF-H. Yes, okay. So MV-F, GDAR, where TMP. Oh, okay, okay. MV-F start, where TMP. Let me see, GDAR. I will I will have a permanent fix later. For now, I'm just copying everything from M2 where TMP. And let me open another tab. But it is going very slow. It will take some time. Just bear with me because there are too many files. The copy is very slow. And now it is gaining momentum. Yeah, now it is a bit faster. Yeah, we know it's a nice session. Let me get on to the GW02. Just give me a moment. I will just watch for some time and then I'll go to GW02. The reason why I'm watching for some time is because it will cause issues for others who are accessing the lab at this time. So I just want to make sure that those who are accessing the lab are safe before I move on to gw02.itverse.com. Yeah, it looks good. Okay. We know that just keep track if there are any issues for others and fix those things as quickly as possible while I demonstrate on the other node. Here I am connecting to gw02.itversity.com. Okay, and then launching PySpark using master yarn and then conf spark.ui.port equal to 12456 and num executors 20. Okay, you guys don't run it because if everyone try to run 20, with 20 at the same time, then definitely there will be major issues on the cluster. Don't do that. Let me demonstrate here. That being said, if you go back to this picture, whatever I have launched on GW02 is nothing but driver program, which will have a Spark context. And there will be 20 executors on the worker nodes that we can actually check by copy pasting this tracking URL, which is generated. I'm zooming out a bit here. Okay. Now you can see I haven't ran anything, but if I go to executors and check, there are 20 executors here and a driver program, which is running on the gw02.itversity.com. Okay, so total 21 executors, one of them is primarily for driver program. And then there is something called cluster manager. If it is Mesos, there will be a Mesos master which will be treated as cluster manager. But as we are talking about YAR, resource manager is primarily to keep track of the resources on the cluster, not at the job level, but at the cluster level. So to keep track things at job level, such as if the job is failing or not, if the data is successfully processed or not, if any task that is processing data have to be failed over, all these things are done by something called application master. So when we talk in the yarn context, this cluster manager is nothing but per job application master or per spark session application master. And to get the details of the application master, here you have to go to this resource manager web interface, resource rm01.itversity.com, column 8088. Similar to name node UI, there is a UI for resource manager also. Okay. And that resource manager web interface will tell what all applications that are running at a given point in time. Some applications might be MapReduce applications, some applications might be Spark applications, because Yarn is just a resource negotiator. It is not the framework to process the data. The framework to process the data is either Spark or MapReduce. If I launch PySpark or Spark Shell or run Spark Submit, the framework will be Spark and it will be running under the umbrella of Yarn in this case. Okay. And you can check this application master. And this is the where the application master is running. So for this session, which I have launched, the cluster manager is running on this node wn01.itversity.com with port number 8042. Okay. From Yarn perspective, that the term which is used to represent this is application master. Okay. Now going back to the Ambari. I'm going to Ambari here. There seems to be a question. I will come back to that in a moment. If you go to Ambari, and if you see the services, there will be a service called Yarn. Okay, there is a service called Yarn. And in this, you can see resource manager and node managers. And you will not see application master here because application master is per session, per Spark job or MapReduce job. It is not per cluster. Only resource manager and node managers are per cluster. Node managers will be running on worker nodes along with data nodes and other slave components. And resource manager will have a dedicated server. In this case, resource manager is running on rm01.itversity.com, whereas node managers are running on the slave nodes wn01 through wn05. Okay. So as we have seen with the binaries with HDFS, same is the case with Yarn. There will be a set of binaries which will be deployed on all the nodes in the cluster. There will be daemon process by name proc underscore node manager for node manager and proc underscore resource manager for resource manager. Same way as we have seen with HDFS. On top of that, there is also web interface for resource manager as we have seen with HDFS, and we have already seen this resource manager UI. Now comes configs. Let me take these questions before getting into the configs. So we will see that we have to first understand the APIs. Then we will actually talk about how to determine number of executors. So don't worry too much at this time. It will take some time. For now, we are only talking about overview of Yarn. We are not talking about the APIs, and you will understand all those things a bit later. So just to set the context, I'm covering these things. Okay. So here we talk about configs. Configs are nothing but properties to control the behavior of Yarn in this case. So each node manager is configured with 24 GB memory. Okay, as we have 5 nodes, 5 into 24 GB, which is nothing but 120 GB memory. Let me sign out as admin. I don't want to make any mistakes. And I'll be logging in as. So admin have admin permissions. Because you have only read-only permissions. Okay, let me use Safari where the password is already saved. So yarn, we are talking about yarn and we are talking about configs. And it is very important for you guys to understand all these typical settings, not the advanced one, at least the typical ones for HDFS and yarn. It's very, very important. And when it comes to node manager, so when it comes to processing the data, all we need is memory and CPU. Okay. So here we are configuring the overall memory for node manager and CPUs. So memory for each node is 24 GB. As we have 5 nodes, the overall capacity is 120 GB. The CPUs we have given is 6. As we have 5 nodes, the count is 30. Okay. This is at each node level and the cluster level. At each node level, 24 GB and 6, which means cluster level 120 GB and 30 CPUs. And we can also get that information from this resource manager interface, where we will get the overall capacity of the cluster. You can see here 120 GB memory and 30 cores. And these values of 120 GB memory and 30 cores is determined by these settings multiplied by the worker nodes on which node managers are configured. Okay. And then executor is nothing but a container. It's not node manager. Executor is nothing but a container. Here we are setting up thresholds for each container. So I have given 1 GB minimum for container and 4 GB maximum per container, and one CPU per container minimum and 6 CPUs maximum maximum per container. So these are container level settings. So if we try to correlate the Spark executor with yarn, it is actually it has to be related with container. So when I say 20 containers, I am creating when I say 20 executors, I am creating 20 containers to process the data. Each one will get the default of 1 GB memory and 1 core. So I'm taking 20 GB memory and 20 cores out of 120 GB memory and 30 cores to process the data after writing the code. Okay. And the reason why they use term container is under yarn, there can be multiple frameworks that can be plugged in. And based upon the service which you are, based upon the framework which you are trying to use, the container, the meaning of container changes. If it is Spark, the container is executor. If it is MapReduce framework, the container is mapper task, reducer task, etc. Okay, so depending upon the framework we are trying to use, the terms representing container to process the data will change. If it is Spark, we call it as executor. Okay, so here you can go to Spark, which is configured with yarn by default when I set up the cluster. And here you can check Spark defaults and Spark env. Okay, especially Spark defaults is the important one. And somewhere, okay, the defaults will not be displayed here. Yeah, you can see here Spark env template. So the default executor memory is 1 GB. So as I'm using 20 number of executors, I'm trying to use 20 GB out of 120 GB memory, which is configured as at the node manager level. So there will be 20 containers in yarn, which will be used to process the data. Okay. So now let me write the code. Hold on to the questions for a moment. Let me write the code and you will understand. Okay. Here I'm trying to write a word count code. So I'm trying to read data. So the session is hanged. So I'm relaunching again. Yes, Shaili, that is correct. It is showing details from conf only. So whatever you are seeing here, whatever you are seeing here, it actually gets the details from the conf. And whatever modifications you make from here as an admin, those things will be saved to underlying configuration files automatically. You should not change from the backend. You have to use tools like Kambari or Cloudera Manager to make the modifications to the properties file. Okay. So that being said, uh, I'm launching the session. I have launched the session again. So first, let me see that there is no session which took 20. Yeah, see here. Yeah, the previous one is still running. So I have to kill this. Yeah, kill. Now I want to launch the PySpark session. So PySpark master yarn conf arg.ui.port equal to 12456 none executor. So here I am overriding the number of executors from 2 to 20. I can also increase the amount of memory. So there is a setting called executor memory. I think executor mem. Let me say set to 2 GB. PySpark master yarn conf arg.ui.port. How come it is complaining? Yeah, I think executor memory syntax is incorrect or something. Or PySpark might not support that. Only Spark shall might. I have to look into that. Let's leave it as executors. Let me also launch the YouTube session. I hope. Let me launch the YouTube session also. And now let me share the screen. So can you guys hear me? Can you guys hear? Uh, Let me see. Can you guys hear me? No. Okay. I don't know why it got muted. Now you should be able to hear me. Are you able to hear me? Hello? Okay, cool. So let me go here. Okay, as it got reconnected. Yeah. Now the session is started. Now I'm reading the data from uh, HDFS. I'm trying to read 30 GB worth of data to fc.text file. This is the path where I have 30 GB worth of data, random text writer, okay, and then words equal to lines dot flat map. Don't worry too much about the syntax and all. You will understand all these things a bit later. Line dot split. This is the delimiter, and word tuples equal to words dot map lambda word comma one, and then word count. I'm just writing a word count program here. Word tuples dot reduce by key lambda total p comma b p plus v. Okay, and then word count dot save as text file user d gargaju wc. That is my output directory, and I'm running. Okay, there is some issue here. What is that? Okay, I logged in as training, so I have to use training here. It is just a permission issue. Now it is running. And if you go to the web UI, okay, if you go to the web UI, I think this is not the one. This is old one. Let me click on running. Application master. As I wrote the code now, you see it is running now. 33 tasks are completed out of 540 tasks, and it is actually processing the data. So what is processing the data? If you go back to the picture and correlate, the tasks are processing the data. Each executor will be running something called tasks, and they are the ones which are processing the data. So driver program is nothing but the session which is launched, which will have the Spark context. On all the worker nodes, there will be executors, and for each session or for each Spark job, there will be application master which will act as cluster manager to keep track of the job progress, whether the tasks are completed or not. If the tasks are failed, restarting the tasks, all those things are done by cluster manager. From Yarn context, it is called as application master. Okay, so this is how the things will be taken care to process the data using Yarn as framework. Okay, and on top of Yarn, there are other frameworks also which are supported with Spark, and that is called Mesos. And none of the certifications emphasize on Mesos that much, so I'm not going to cover that. That being said, that gives the brief overview of Yarn. There are certain commands which you need to be familiar with when it comes to Yarn. I will explain that in a moment. Once the job is completed, I will explain. So here I am trying to process 30 GB worth of data to get the word count, and you can see the tasks are being created and processing the data, changing to completed state, and then taking care of pending tasks. And slowly, all the tasks are being completed, which means that it doesn't require that you need to have uh, um, resources pre-configured to support the entire data set in one shot. It's almost done. It will take another minute. That is correct, Shaili. On average, 4 per node, not 5, 4 per node on average. Some might be running 6, some might be running 4. It all depends upon the load balancing, the load on the cluster at that time. Okay, now it is done. We'll come back to this word count program and all those things. We'll write word count program later. For now, I'm just exiting here. And you need to know some important commands when it comes to yarn. It will help you in troubleshooting, killing the jobs and all those things. So you can say yarn application and hyphen hyphen list to list all the jobs that are currently running on the cluster. So Manoj, Sharath, and Aroy are actually running something on the cluster using Spark Shell. Similarly, if I say list all, it will show us 1 minute. I think syntax is not correct. To get all the commands under yarn application, we can just say yarn application and hit enter. There is a list command. There is a help command, so we can actually say help list. Okay, it is not showing. Okay, let's read. List application supports was optional use of app types to filter applications based on application type. So let me run yarn application hyphen list all. Why it is not showing all? Okay, here it is saying total number of applications for submitted, accepted, and running. There should be a way to get all the works with list. Yeah. So if you want to get all, you have to say hyphen list hyphen app states all. Yeah. Hyphen app states all. Then it will give all the yarn applications that have ran since the restart of the yarn. Okay. Like that, there are others also. Yarn application hyphen help. One of the important thing is kill. If there is any hanging application, and if you want to kill, you can use hyphen kill. And you can change the queues. I don't want to get into queues and all at this time. So these are the handful of commands which you have to be familiar with respect to yarn, so that you can actually support your applications with a bit more reliability. Okay. So that being said, that is it when it comes to understanding the overview of yarn. And we will see these things a bit in detail later, and you will understand even if you don't understand completely at this time. It's just a starting point. Okay, let me zoom out here. Uh, okay, so the next thing is launching PySpark, which I have already covered, and set up datasets, which is also covered. So as it is a logical conclusion of the module, we'll get on to building blocks for Spark applications using Python tomorrow. As we have some time, I will highly recommend you uh, to do certain things. When it comes to uh, using the Sigwin with PySpark, I have tried to troubleshoot and fix the issue. What I got is they are asking to use command prompt only to launch PySpark. No one is recommending to go with Sigwin. Okay. For that reason, as we have time, everyone can actually launch CMD and run PySpark here. Okay. Definitely, almost all will get issue that is given because it's Windows. and I will try to help you how to come how to work around it in a moment. So here I am launching PySpark on my PC, not on lab. Okay, and it is very important for you to launch PySpark on your PC. For me, because I troubleshooted and I fixed the issues, it launched it successfully. So depending upon the errors you get, I will do the screen sharing and fix for the people, and we will try to resolve the issues as much as possible today. If not, we will take care of tomorrow. Okay. So launch command prompt. Go to search and search for CMD and launch command prompt and run PySpark. And if there are any errors, let me know. I will try to troubleshoot and fix those issues by doing the screen sharing. Okay, now I'm getting. Okay, Sumit, you are getting. Okay, most of you guys are getting Python is not recognized as an internal or external command. Okay, so let me start with Dheeraj. Dheeraj, can you share your screen? I'm stopping my sharing of my screen. You can share your screen, and I will fix that issue, and the rest of you folks also follow that. Getting a different error. We will see that Vamshi in a moment. Okay. So Dheeraj, first thing you need to whenever you get this issue in Windows of uh, not recognized as an internal or external command, that means you have to set up the environment variable. So go to environment variables. I will not be able to make any changes here because Windows does not permit to change environment variables remotely. In the search, type for environment variables. Okay, and yeah, you have to change the system environment variables, not the user environment variables, and then double click on path. And double click on path. Okay, 1 minute. Go to browse. Click on browse. Click on browse, and go to this PC. Expand this PC. Go to C drive. Most likely, your Python should be in C drive. See if you have Python in C drive. Scroll down a little bit. Yeah, Python 27. Yeah, and expand that. Yeah, you just have to choose that Python 27 and click on OK. Click on OK here. Click on OK. Exit from command prompt. Click on OK. Exit from command prompt and launch the command prompt again. Yeah, now run PySpark. So those who got that Python is neither internal or external command, you have to fix your environment variable, add python.exe, the directory which have python.exe to path environment variable. Okay, these can you show them again just in case? Go to search and open. This is another issue which I will fix a bit later. At least one issue is resolved. So go to environment variables. Click on environment variables. Click on path. Yeah. So they have to click on. So from here, no, don't click from here. Let them figure out where their Python is and pass the proper path. Okay. So I will give half-minute time here. So make sure every one of you um, get this issue resolved of uh, Python not recognized as internal or external command. It is purely on environment variables. Anytime if you think that the software is there but is not running from command prompt by with the error of not an internal or external command, that means you have to fix environment variable. You have to update your path. That's the thumb rule which you can follow. Now you can close this, Diraj. Let me check what Vamshi's issue is. No, Vamshi, this is not same as Diraj. Okay, okay. Probably the new, it could be same as the new issue. Okay, we will get to that in a moment. So next thing, what you have to do is, Diraj, can you go to browser and open google.com, and everyone have to follow this after fixing that Python issue. So search for winutils.exe, discuss.itversity.com, winutils.exe. Yeah. No, no, space winutils.exe. Don't no need to search for it. He will give the link .exe. Only one S, not two S. Yeah, .exe, and hit enter. I think you have to choose the second one. Error in Sigwin while running. No, no, not. Yeah, let's try that. Let's try that. Yeah, scroll down. Yeah, this is the one. So you can actually share this link with others. No, no, not that link. The discuss link with others. Okay. Now everyone have to first download this file, winutils.exe. Download that file. Click on download. First follow what I'm trying to explain, and then you do it. And if you still have any issues, uh, I will explain later. Yeah, save as. Click on save as. In the C drive, first create a directory, Hadoop. Yeah, Hadoop. Double click. Bin. Yeah, double click. Oh, you already have. Okay. Then yeah, click on save. Okay, so everyone have to do this, and then go to environment variables. Yeah, and then go to first you have yeah, you already have Hadoop home. So you can see here, Dheeraj already created Hadoop home. Remove that backward slash in the end, Dheeraj. Just have C:/Hadoop and click on OK. And go to path now. Double click on the path. And have you already added? No, you haven't added. So click on browse. Click on browse, and then go to C:/Hadoop. C:/Hadoop, and win, and click on OK. Say OK. Click on OK. Click on OK. And then open the command prompt. Close the existing command prompt. Okay. Open the command prompt. And run WinUtils, and hit enter. Yeah. So it should be fine now. Now run PySpark. Okay, still it is giving the same issue. That is weird. Uh, no, that is not the problem. I know what is the problem. I see here we don't have Hadoop. It's WinUtils is just a kind of fake thing. It's not real thing. So it should work. If you are getting access is denied, let me think where the problem is. Hmm. Yeah, it's the problem with Spark Home. Exit from here. Exit from here. Go to environment variables again. Exit from here also. You can exit from command prompt completely. And then go to environment variables once again. And click on path. No. Spark Home, yeah. Is that the right path? Whatever you have in the Spark Home. Confirm that it's the right path. You can click on edit. Click on edit and get the path and go to Explorer and try to open that path. Yeah. You copy that path, whatever is in the variable value. Yeah, you can actually click on browse directory. Yeah. And then choose. No, it will be in the C drive. Where is your Hadoop Spark installation? Scroll up a bit. Yeah, Sigwin 64, I think. Home. Yeah, Spark one. Yeah, that one. Yeah, click on OK. That is the Spark Home. Yeah, click on OK. Okay, and then double click on path. It looks fine. Mhm. Okay. Now remove this Spark Home / bin from the path. Yeah, remove that. And then browse. Click on browse. And now choose the path. PC. Home. Bin. You have to choose bin. And click on OK. Click on OK. 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 Now launch PySpark. Ah, how come? Go to environment variables. I think the order also matters. Click on path. Click on path. Where is your Python thing? Yeah, that's why it failed. Now click on browse. No, don't select that. Yeah, just click on browse. Oh, it's okay. Now you can. I think earlier you edited it. Now you just click on browse and go to your Python 27 in the C drive. Yeah, that's it. Okay. Okay. That's what actually I think. Now click on new. I think you have to click on new and then browse. That's why there is some confusion. Click on new and then browse. Now you can browse and C drive Hadoop bin. Yeah. Click on OK and let us verify others also. Make sure we have Hadoop Home and Spark Home. Scroll up a little bit. There's Spark Home and let us see Hadoop Home as well. Yeah. Now click on OK. Now launch the command prompt. So this is the problem. Even if I try to document this, all the permutations and combinations with Windows is making it a bit challenging. Yeah, still it is not. Come out of it and launch Spark Shell and see if the Spark Shell is launching. Okay, now it is giving some other error with respect to Spark Shell. That's fine. Ignore it for now. So I will try to figure this out. Okay. Now it is okay. Earlier it was Spark equal to Shell. Let us see if the Spark Shell launches. I think Spark Shell is launching. So others, please go through this. I hope everyone is not getting the exception of Python is not internal or external command. Up, make sure you go through this link and set up that winutils.exe and all. And I will take it from there either tomorrow or I will sit with dealers over the weekend and get the issue resolved. And then I will. In my case, I got the similar error, and whatever I have done, I have explained to dealers. Thing, but still we are getting the same exception. And Windows, the others are not very informative, so it is a bit challenging. But I will try to get it resolved. Others, let me share my screen. You can stop sharing, Dheeraj. If the PySpark is not recognized, then you have to add those things to path. You have to. It's purely environment variables issue, and I will show you tomorrow if it is not resolved by tomorrow. Just try to add the environment variables so that the PySpark is accessible to you. What you have to do is go to environment variables and make sure you play with the system variables. Yeah, one more thing, Dheeraj, before we wrap up, what you do is launch the CMD, right click on it and run as administrator. And then run PySpark and see if it works for you. Okay. For Shravya, uh, you just go to environment variables. Okay. So here we are talking about PySpark is not being recognized. So make sure the bin directory of your Spark installation is part of path. Then it will work. Okay. Yeah, yeah. So whatever I tell, I mentioned, it will work. So let me see here. I am exiting and launching CMD here and testing PySpark. And let me see if I also get access denied. No, I'm not getting access denied. So it's a different issue, Dheeraj, for you. I need to see. Yeah, that's fine. We will have a look at it. Okay, so it's coming for everyone. Let me quickly check what I have done in my environment variables. Yeah, I know where the issue is. I know where the issue is. Um, okay, let me. So that's what, Karthik. You have to go through that URL which I have shown, and you have to set up your Hadoop home directory after downloading winutils.exe. So go to this link and try to get it resolved. If not, raise the issue in discuss.itversity.com. We will try to support you. Okay. So let's move on to the other issue. After setting up the WinUtils. So let me review my environment variables once again and see where the issue is. Okay, Spark Home I have. I would recommend you one more thing. What I have done is you go to PyCharm. Okay, you launch PyCharm. Let's try this. You launch PyCharm. Why it is taking so much time? Why it is taking so much time? And now it came back. One more thing I have done is I went to PyCharm, click on run, go to edit configurations, and as part of this, I have added environment variable Spark Home here also. So just expand this and create a environment variable here also. Once you set this, probably it might fix the issue. The Spark Home environment variable, try to set up here also. I'm not sure whether it will fix or not, but this is the only difference which I can see between theirs and mine. And probably this could be the reason. I'm just doing it trial and error basis. If we could not resolve this issue by tomorrow, I will sit with Dheeraj over the weekend, or whenever, or some other guy who have time over the weekend because it's a long weekend, and then we will come back with a solution. Yeah, this is the problem with Windows. So if everyone gives up Windows, it will save at least 20% of my time. Okay, so that being said, thank you very much. We'll catch up tomorrow. And those who are attending the session on YouTube, thank you very much for joining the session. If you want to practice the way I am demonstrating on the as part of the sessions, you can sign up for our lab at labs.itversity.com. In case if you have any issues while setting up the environment or while learning at your own pace by following the content, then please just give me a moment. Please raise the issues on discuss.itversity.com. Okay, discuss.itversity.com is the platform where we can answer your questions, and labs.itversity.com is the is where you can subscribe for our lab, and you can start practicing the way we are demonstrating. That being said, if you like the content, please click on the like button. If you want to share with your friends, you can click on share, and you can share on your social networking platform so that. If you have any feedback to share with us, wait until the video is streamed, and please comment as part of the comment section of the video. That being said, thank you. Bye.